speed of light. Is the speed of light a constant? The answer is yes, but only in one medium. So as light goes from one medium to the other, the speed changes. So the speed of light in air is equals to the value of c, which is 3 times 10 to the 8 meters per second. But when it goes to another medium, say water, this speed of light has to be divided by the index of refraction of that medium. So the light will go slower in an optically denser medium than air or vacuum. So light is an electromagnetic radiation, yes? Electric field is altered by a factor k0, which depends on the dielectric constant of the material it's going to. So what you do when you go from electric field in air to an electric field in medium, you replace epsilon naught by ke epsilon naught. So speed of light in a medium also depends on the electric and magnetic properties of the material themselves. So for you, the important thing to remember is as light goes from one medium to the next, C will now equals 1 over mu naught epsilon naught, which is the permeability and the permittivity of free space. So as light travels from one medium to another, it changes. It changes its speed. However, its frequency will not change as it goes between one medium to another. So think about it this way. So a red light will remain a red light because that depends on the frequency, right? So as light goes from one medium to another, red light will not turn into green or blue or purple or something like that, right? It remains a red light. So the frequency of the light will not change. However, its speed and its wavelength will change as it goes from one medium to another. Now this change of wavelength is going to be given by n equals c over v equals lambda naught over lambda n, or lambda 0 over lambda n, where lambda 0 is the wavelength in vacuum and lambda n is the wavelength of medium with a refractive index n. Okay, so remember, wavelength will change, speed will change, frequency will not. Red light will remain a red light. Now let's do an example. Wavelengths change from glass to water. The index of refraction of glass is 1.50 and that of water is 1.33. If a light of wavelength 285 nanometers in glass passes into water, what is the wavelength of light in water now? So in this particular case, it says that we have a light that is passing from glass into water. So it says what is the wavelength of light in water? So it gives us n of our glass equals 1.5. It gives n of water as 1.33. It gets lambda in glass as 285 nanometers. And it says lambda in water is what we are looking for. So how do I solve this? Well, first things I know, obviously, that index of refractions are different, so the speeds are going to be different. And I know that lambda g is not going to be the same as the wavelength in water. But what do I know? I know that the frequency in glass has to equal the frequency in water. That is going to be very, very useful. What else do I know? I know speed equals lambda f. That means that my speed in water, and speed in glass will equals lambda glass and lambda glass and frequency glass. So this is what I know. Okay? What else do I know? I also know that V equals C over N. That means that V in glass equals V in glass and V in water equals V in water, where C is the speed of light in air, right? So these are the two things I know. Now how do I combine those two things in order for me to calculate F, in order for me to calculate lambda W? Okay, I am looking for lambda W, so I can be very, very careful. Ooh, oops, this should be lambda W, right? Okay, so how do I do this? I know from equation 1, I know from 1, VW equals lambda WF, right? FW. If I replace this is what I'm looking for. Lambda W is what I'm looking for, right? I know if I can replace FW with FG here, will it make a difference? The answer is no, because FW equals FG. So I can, in fact, replace this here. VW from equation 2, VG lambda G equals lambda W. So I replaced it from here, right? Now, what else do I know? So this is from equation 2. So from equation 2, I replaced this. What else do I know? I have equations 3 and equations 4, right? I don't know what the speed is in those particular mediums, but I do know the values of these two things. So from equation 3, I can plug in this value, and from equation 3, I can plug in these values. Okay? So what do I get? I get lambda W equals C over NW divided by, from equation 3, I get C over NG times lambda G. Good so far? Okay, now these can be rearranged to give me C. Well, the C's go away, and I can replace these, because this is 1 over NW, by NG over NW lambda G. So look at it very carefully, right? What did I have? I had 1 over NW divided by 1 over NG lambda G. So it's just a matter of rearranging these, okay? Once I have this, then I have everything according to what I wanted. NG, NW, lambda G. Just plug in the numbers, and you get lambda W equals to 321 nanometers.